In the face of rapid deforestation in the Amazon rainforest, where an estimated 18 trees are lost every second, scientists are turning to an unexpected source for solutions: the soil management practices of ancient Amazonian civilizations. This 2,500-year-old legacy, known as Amazonian Dark Earth (ADE), may hold the key to accelerating reforestation efforts and combating climate change. Let's delve into the fascinating world of ADE and explore how this ancient soil could shape the future of forest restoration. The Amazon rainforest, a carbon sink under threat. The Amazon rainforest, often referred to as the lungs of the Earth, plays a crucial role in maintaining our planet's carbon balance. As the world's largest rainforest, it absorbs vast amounts of carbon dioxide, helping to mitigate the effects of climate change. However, the Amazon is facing unprecedented threats from deforestation, primarily driven by agricultural expansion, logging, and urbanization. The loss of this vital ecosystem has far-reaching consequences, not only for local biodiversity, but for global climate patterns. As trees are cut down, they release stored carbon back into the atmosphere, contributing to the greenhouse effect and exacerbating climate change. This vicious cycle makes the need for effective reforestation strategies more urgent than ever. The challenge of reforestation. Reforestation is not as simple as just planting trees. The process of restoring a forest to its former glory is complex and time-consuming, involving intricate ecological interactions and succession patterns. One of the major challenges in reforestation efforts is creating the right conditions for diverse plant species to thrive, especially in areas that have been degraded by human activities. This is where soil quality becomes paramount. Healthy, nutrient-rich soil is essential for supporting the growth of a diverse range of plant species, from pioneering grasses to towering canopy trees. However, in many deforested areas, the soil has been depleted of nutrients and beneficial microorganisms, making it difficult for plants to establish themselves and grow. Amazonian Dark Earth, a pre-Columbian solution. Enter Amazonian Dark Earth, a type of highly fertile soil found at archaeological sites throughout the Amazon basin. This remarkable soil, also known as terra preta, was created by pre-Columbian indigenous societies as far back as 450 BCE. To put this in historical context, this was around the time when Sun Tzu was writing The Art of War in ancient China, and well before Alexander the Great began his conquests. What makes ADE so special is its rich nutrient profile and its ability to maintain fertility over millennia. It contains high levels of essential plant nutrients such as carbon, calcium, phosphorus, zinc, iron, and copper. But perhaps even more importantly, ADE harbors a diverse community of beneficial microorganisms that play a crucial role in nutrient cycling and plant health. The exact origins of ADE are still debated among researchers. Some believe it was intentionally created as a soil amendment for agriculture, while others argue it's a byproduct of long-term human habitation. Regardless of its origins, the effectiveness of ADE in promoting plant growth is undeniable, even after thousands of years. The composition of Amazonian Dark Earth. The unique properties of ADE stem from its diverse composition, which includes charcoal, remnants from cooking fires and slash-and-char agriculture practices, which help retain nutrients and water in the soil. Organic matter, decomposed plant and animal remains, including food waste, that enrich the soil with nutrients. Pottery fragments. These can help improve soil structure and water retention. Bone fragments, a source of phosphorus and calcium. Diverse microbial communities, bacteria and fungi that play crucial roles in nutrient cycling and plant growth promotion. This combination of elements creates a soil that is not only rich in nutrients, but also has excellent structure and water-holding capacity, making it ideal for supporting diverse plant life. Harnessing ADE for modern reforestation. A 2023 study by Brazilian scientists has demonstrated the potential of ADE in accelerating forest restoration. The researchers conducted a simulation to test how well ADE could support plant growth in a scenario mimicking the succession of plants from a cattle pasture to a restored forest. The experiment. The study involved 3 stages: simulating a cattle pasture by growing common Brazilian pasture grass in 3 soil conditions: 20% ADE, 100% ADE, and regular agricultural soil control. After several weeks, the grass was cut, leaving only the roots to mimic the transition from pasture to forest. Plants representing 3 stages of forest succession were then grown in the same pots, under conditions simulating a warmer climate, around 34 degrees Celsius, to account for future climate change scenarios. The results? The findings of this study were remarkable. Soil with just 20% ADE showed similar plant growth to 100% ADE for secondary and climax plant species. ADE-enriched samples maintained a greater diversity of beneficial microbes compared to the control soil. The enhanced microbial diversity in ADE-enriched soil supported better nutrient uptake by plants. These results suggest that even a relatively small amount of ADE can significantly improve soil quality and support the growth of diverse plant species, potentially accelerating the process of forest restoration. The mechanism behind ADE's effectiveness. The success of ADE in supporting plant growth can be attributed to several factors. Nutrient retention. The high carbon content of ADE, particularly in the form of charcoal, helps retain nutrients in the soil, preventing them from being washed away by heavy rains. Microbial diversity. ADE supports a rich community of beneficial microorganisms, including bacteria and fungi, which play crucial roles in nutrient cycling and plant growth promotion. Improved soil structure. The diverse components of ADE, including charcoal and pottery fragments, contribute to better soil structure, enhancing water retention and root penetration. Long-term fertility. Unlike many modern fertilizers, the benefits of ADE persist over extremely long periods, potentially thousands of years. Implications for future reforestation efforts. The insights gained from studying ADE open up exciting possibilities for enhancing reforestation efforts. Soil enrichment. By mimicking the nutrient profile and microbial composition of ADE, scientists could develop super soils tailored for specific reforestation projects. Accelerated succession. ADE-inspired soil amendments could potentially speed up the process of ecological succession, allowing forests to recover more quickly from disturbances. Climate resilience. As demonstrated in the Brazilian study, ADE-enriched soils can support plant growth even under warmer conditions, potentially helping forests adapt to climate change. Sustainable agriculture. The principles learned from ADE could also be applied to sustainable agriculture, reducing the need for chemical fertilizers and minimizing the environmental impact of farming. Challenges and considerations. While the potential of ADE is exciting, there are several challenges to consider. Limited supply. Natural ADE is a finite resource, and excavating it for large-scale use is not sustainable. The focus should be on recreating its beneficial properties rather than using the original material. Site-specific adaptation. The exact composition of ADE that works best may vary depending on local conditions, requiring careful adaptation for each reforestation project. Long-term studies. While the initial results are promising, long-term studies are needed to fully understand the impact of ADE-inspired soil amendments on forest ecosystems over decades. Ethical considerations. As we learn from ancient indigenous practices, it's crucial to acknowledge and respect the cultural heritage of Amazonian peoples and ensure that any benefits derived from this knowledge are shared equitably. Conclusion. Learning from the past to secure the future. The story of Amazonian dark earth is a powerful reminder of the wisdom embedded in ancient practices. The indigenous peoples of the Amazon, through their land management techniques, created a legacy that continues to offer solutions to one of our most pressing environmental challenges millennia later. As we face the daunting task of restoring and protecting the Amazon rainforest, ADE provides a beacon of hope. By understanding and replicating the properties of this remarkable soil, we may be able to accelerate reforestation efforts, enhance the resilience of restored forests, and contribute to mitigating climate change. The journey from ancient soil practices to modern reforestation techniques illustrates the importance of interdisciplinary research and the value of looking to the past for solutions to present-day challenges. As we move forward, the lessons learned from Amazonian dark earth may not only help save the Amazon, but also inform sustainable land management practices around the world. In the end, the story of ADE reminds us that sometimes the most innovative solutions are rooted in ancient wisdom. As we strive to protect and restore our planet's forests, we would do well to listen to the whispers of the past echoing through the soils of the Amazon.